This is this is Algvis. It's my OCR Computer Science NEA project, and it's a piece of educational visualization software to help people learn about common algorithms. So you can launch it, and you can minimize it, maximize it again, and you can resize it so it fits various different screens. So the first place a new user will be likely to go is the tutorial, and here you can interact with some elements. And these don't have an effect on the main solution, so you can just play around on your own without affecting the main solution. So you can toggle these buttons, you can interact with widgets like this, you can try entering some data here, and it'll tell you if you're incorrect. The data can be read. For example, this is a string, type in -1, needs to be in the correct range. I'll go into this more later, just showing that the tutorial widget also works. Put it in the correct data, then it will tell you. Also the play button here, I'll colour them all blue, just so you know that your input's been read. And this will help them learn how the solution works. And you can, as you might have seen, you can go forward and back. If you try to go back on the first slide, then it won't work. And if you try to go forward on the last slide, you'll go back to home. So you can go back to algorithms or options, whatever you want to do. The back button also works just as well. And in the options menu, you can turn on or off these buttons. This will affect what is shown in the visualization screen. So you can see here, everything is shown. If you turn them all off, you will see no extra information is shown. If you turn some on and some off, then only some data will be shown. Turn them on for now. And you can also toggle them on or off as many times as you like. And that will be still reflected in the main screen. Get onto the algorithm select. So here you can click any of these. It will give you a description and the title. It will also give you a button you can use to go to the visualization screen. Some of these I didn't get time to add, unfortunately. These buttons are coloured in purple, so you know they don't work. Also says coming soon, just to illustrate that. Okay, and so if you go to the bubble sort quickly, you can change these and it will change how the solution works. You can enter your own data. That's correct data. You can click random data, say 10 for the random elements, and that will be shown. If you click the start button, these buttons won't work, just because you can't enter your own data while in the visualization. It doesn't really make much sense. The visualization is still in progress. So if I go back and re-enter here, the data you entered will be saved, but it'll go back to the beginning of the visualization. So I'll show you the progress of the visualization. So it will raise these bars out and swap them and then put them back into the data set. You can speed it up. Turn quickly. And then at the end it will go green just to show that it's completed and it's now in the correct order. You can restart it and it will do the exact same thing. You can also pause the visualization while it's running. You can go back and go back in, or you can just restart it. This will work. Say it's finished and restart it, and we'll try it again just to illustrate that it always works. There you go. And so I'm showing you can enter custom data through here. You can also enter random data, but without invalid data. So if you enter just some gibberish, it won't be read. If you enter a float value, as well as some other data, again, it won't be read. It will tell you why. Put it at the end. Again, won't let you use floats. If you put it in an incorrect format, such as, I don't know, you might use that as your separator for some reason, then I'll tell you why. I'll show you the format. Some formats are acceptable. For example, if you put commas without spaces, it will enter data correctly, but also inform you of the correct way to enter your data. Just do the same with spaces. Okay. If you have a lot of data, then, or a lot of data, it'll tell you that you can't have more than 50 digits, 50 integers, sorry. Go all the way back and put in, this time we can have digits such as outside the range. So 1000, so 10. You can't have -1. You can't have over 10,000 either. And yeah, it won't accept any incorrect inputs. Random data is similar. You can't just enter gibberish. It will ask you to enter a single integer. You can't enter multiple digits. You can't enter, say, a float. You can't enter a really large number of digits. Okay. The maximum is 50. So if you enter 55, so you'll go over. Tell you that's too large. Put it at the boundaries, so at 50 to at 1. You can do that. 1 does actually work. It will just be automatically sorted. It will be sorted as there's nothing to swap it with. It's only one digit. And we'll leave it at 10 for now, and I'll show you the rest. So you can enter your own data here as well. Works the exact same way as before. Here you can also enter a search value. So, say we wanted to look for the element 6, it'll go through the data one by one, as any search does, until it finds the correct bar. If it's not in the list, then as you can see, it will go red to show that the element hasn't been found. This is the same for binary search. If you put in some more data, show you that it still works. Like that. And say we're searching for the element 2, then we'll move the pointer down until it finds it. It's not in the list, say like 20. Then it'll perform binary search, but when it gets to the end, it'll realise it isn't there, and it will go red to show that the element hasn't been found. It also works if it's within the data, say like 8. Yeah. And you can see that it wasn't found, and so it went red. Okay. So you can't enter a string, so you put it in like that. Ask you to enter integer, and also can't put in a float value like 5.5. It'll ask you for an integer until it receives one, and you're still entering data. Okay, so I'll show you that all the algorithms do indeed work. I've shown you linear search, I've shown you binary search, I'll show you bubble sort again, just because you might not have seen it the entire way. Search and sort. See, it's putting in the bars in the correct order in the sorted list here. Merge sort. The red symbolize pointers, and they show the start and the end of each sublist. And then when it swaps, it will move them back in. This is it joining the two lists together. Quick sorts, it will select a pivot element and move everything small in it to one side and everything large in it to the other side, as you can see. And now radix sort. This is a sort where it will check the last digit and put it in a bucket depending on its digit. Then it'll go down there to the most significant digit, and then it will dequeue it from the bucket each time, and then it'll be in the correct order. So you can see it working here. It's being put in the correct bucket depending on its last digit. You can also see here an extra bit of information you can see, show you which digit is being looked at. Then it will be moved out, dequeued, as you can see. It will be the first one that's put in will be moved out. And this will continue. And it will continue until it's in the correct order, as you can see. This also has the exact same validation. Can't enter strings. Can't enter floats, etc. Also can't enter strings or floats in here. Also has the same range checks as the others. You can enter your own data here, and it will adjust the visualization based on the length. So here it's only got a maximum of 3 digits. So you see here, there'll only be 3 digits here, and these will be shown larger. This works as well. Make it a bit faster. There you go. Same. You can also enter random data if you want, and you can watch the algorithm if you like. See, it works in the exact same way, just with more data. And it's done. Now I think that's it. So thank you for watching. I can show you that it does indeed close correctly. And yeah, thank you.